Okay, this is the second half of the review video for the Q3 cumulative test. This will pick up after the first 10, and a bunch of these are nothing more than recognition calls, judgment calls. This is a perfect example. Do these make good statistical questions? Remember, the issue about statistical questions was that was there any sort of variation in the answer? And did it require collecting data to answer the question? Now, a quick way to not have a good statistical question was to answer something that could only have one possible answer. You want something with some variety to it. All right. 11. During which month of the year does Cadbert sell the most ice cream? In order to know that, you're going to have to look at the other months. And so there's some variety there. And so that would make a decent statistical question. The question is now, is the data going to be numerical or categorical? And ultimately, you're talking about which month, which that is a categorical thing. So this is a good question, and it is categorical. When you start answering, your answer is in terms of January, February, or March. Those are categories, not numbers. Numbers are like, what's the average weight of every player on the basketball team or something like that. All right, how much ice cream did Cadbert sell last June? That's going to be something that, there's one right answer to that. There's no variety to it. You look up on the records and there's the bottom line. He sold, $1,000 worth of ice cream. And so that's not a good statistical question. Now, what is Cadbert's average daily sales for last June? That's a different story. That's forcing you to look at, the numbers for each day and compute an average, and each day is going to have a different average. So that's a good statistical question. And if you're talking about average daily sales, that's not a category. That's, your sales one day is going to be $100 and the next day is going to be $120. Those are numerical answers. So that's the three responses that we're getting there. All right, survey, observational study, or experimental study. Head custodian has been using brand A floor wax, is wondering whether brand B is a better choice. Well, the one way for him, this is not something that he's going to want to go and watch somewhere. I mean, who watches people wax floors? And it's not something that you really can do a survey. You can survey other high schools and see what they've come up with. But really, the best way to know for sure is to use brand A on one hallway and use brand B on another hallway and see which one holds up better. That would be an experimental study. Because you would have one hallway that is the group that gets no changes whatsoever. They get the same thing. But then there's the other hallway that's getting the new wax. And so you're watching the two to see if there's a difference between the two. And so that's an experimental study. Do high school students prefer mozzarella or Italian blend cheese on their pizzas? That is something that a survey could definitely answer. Do students use the media center to study or for social purposes? Now, yes, you could survey them, but probably the easiest way to get your data is just to stand at the door and watch, as they come in. Are they, going to a corner and pulling out books and a laptop and doing homework, or are they sitting there chit-chatting? That's something that an observational study would probably be because if you ask them, what are they going to say? Yes, I come here to talk. Well, that's going to get them kicked out. So that you run into some bias at that level. but you just sit there and watch. You're going to get your answers. So, all right. Next set, method of sampling. As I recall, there are actually, there are 6 ways of doing samples. So let's see, Egbert wants to find the favorite brand of smartphone among those students. So he stands at the front of the school and surveys students as they're waiting for their ride. That's the person that stands in one spot and lets them come to him. That's convenience. Gerbert surveys all female juniors. Now, just to be clear here, there's one category that says all the females, and there's another category that says all the juniors. And so he is doing layers here. This is stratified. Because when he says all female, that cuts off one part of the group. And when he says juniors, that cuts off a different part of it, so that there are, it's like you're cutting your cake from 2 different angles, and what piece is left, that's what your sample is. All right, he leaves a printed survey at the cash register, the lunch line, and posts collection boxes at all exits of the cafeteria, which sounds like, if they want to, they can fill it out and leave it in the box. Does everyone do that? Probably not. You are probably looking at voluntary response here. They have to choose to participate. All right, he goes down the school roster and seeks out every 100th name of the survey. That is simple random. Okay. Gerbert puts all the student names. Oh, wait a minute now. No, when he draws the 100 names, that's the simple random. This guy is going to be all right. Oh, golly. All right, it's not random. Whoops, I need my eraser, don't I? All right, I've been interrupted about 3 times in the middle of this. We're talking about systematic random, systematic sample here. Because there was a system to it. Every 100th name was the clue there. Every 5th name, that sort of thing. That's the system. Now, just drawing 100 names total randomly out of a bowl, that's a simple random sample. Now, Gerbert surveys every student in the 1400 hall during first block. In the 1400 hall, and if I specified first block because I know that you change classes, and 1400 hall may have a completely different set of kids from one block to the next. So 1 block, and he's doing the entire 1400 hall. That's a cluster, where he's just trusting that the sample that he gets from the 1400 hall is representative enough of the rest of the campus that he can move on with trying to figure out who likes what smartphone. Now, Norbert is trying to find the favorite soft drink among Anglo students. And we're determining what kind of bias he will encounter in each situation. All right, he decides to survey the home rooms, but he has trouble getting responses from room 1249. That would be non-response. When people are just simply not doing it, that's non-response. Now, when they're doing it and lying about it, that's a response bias, but this is a non-response bias. All right. Norbert gives his Instagram account on the lowdown, encouraging students to vote with a selfie of their favorite soft drink. You're still leaving it up to the person whether or not they want to participate in not. Now, true, who's going to refuse doing a selfie with their favorite soft drink? That's not a bad plan, but he's still going to have lots of people left out because they don't feel pretty enough to do a selfie, no matter what the drink is. And there are some that don't even have an Instagram account. So, this is very much a voluntary thing. People are only going to respond when they're interested. All right, so Norbert asks students if Pepsi is their favorite drink. That's, it's like you're assuming that, yeah, you're going to like Pepsi, aren't you? Aren't you? That's question wording. You need to say, something more like, what is your favorite drink? Not, is Pepsi your favorite drink? Question wording. All right. Now, Norbert knows that the basketball team favors Sprite, and so does every student in every PE class. Now, what he's beginning to wonder is that are the PE students saying they like Sprite just because they like the basketball team or something like that? This would be a response kind of situation because he's afraid that this group is lying. All right, they're not responding truthfully, and that's a response bias when you think that somebody is not being truthful for whatever reason. In this case, maybe they idolize the basketball team, maybe they want to be cool like them. Who knows? And then lastly, Norbert decides to ask the students in his 4A class. Now, that's going to be one of those situations where out of a campus of 2,400 students, and he's asking the 25 people in his class, in just one class, that's not going to be big enough. This is a classic case of under coverage because the sample that he has taken is so small that there's not really any way that you can expect them to represent the rest of the campus. All right, now we have these, which is actually kind of a review of Math 3. And honestly, this is something where we can go to Desmos to the rescue. If we type in a table of these numbers, and we say 85 and 90 and 90 and 40 and 100 and 75 and 80 and 95 and 70 and 185. All right, let me make sure I type those correctly. That looks good, and all right, we're good. Now, that is going to be table X sub 1. So if we want to go into these guys, we can find, what was it I discovered? Oh, come on, brain. Total? Was it total? That gave us, no, that's not it. That just adds them up. Maybe it was this. Well, we can throw all of these. Oh, there was something on here. Stats. That was it, I'll bet. Yes, it was. You type in stats, and it gives you a bunch of these. The Q1 value was 75. Pardon me. The median, which is the Q2 value, 85. Q3 is 95, which you can calculate your own interquartile range, which is basically Q3 minus Q1, 95 minus 75. which is 20. Now the mean, we're going to have to come back here and do the mean of x sub 1. And the mean is 82.72, repeating. That's about as exact an answer as you can get. And then standard deviation of x sub 1 is 17.08, yada, yada, yada. All right, so there are your numbers there, which, like I say, all of this under functions and stats. And that's what it was stats gave me all of the Q quartiles at the same time. All right, so there's those. That was quick. Now, tell whether these are better suited for categorical or quantitative data. Oh, this goes back a ways, doesn't it? The real the real sticking point is categorical, because categorical does not do normal distribution curves. You can't have January, February and have a normal curve on that. You can have a bar graph. You can even have a circle graph with categorical. A scatter plot, not really. Scatter plot's more in terms of X and Y. And you're talking about categories here like January, February, and March. So the rest of these are ones that are better off with quantitative data, numbers that you can have, decimals and fractions if you have to. But like I say, these guys are better. Well, I guess with circle graph, no, it's really hard to have a quantitative thing with a circle graph, because how do you distinguish pieces of the circle except for the categories? So yeah, you can't do quantitative with circles. All right, what makes a histogram different from a bar graph? A histogram has intervals, and I guess you could even say quantitative intervals, like from 10 to 20, 20 to 30, and so on. Whereas a bar graph has categories. You've got a bar for January and for March, and these intervals make it difficult to give specific answers to things. When you're looking at a histogram and somebody says, what's the mean? What's the median? Those are difficult. You can come up with something of the median, but the mean is almost impossible with a histogram. You can get something close to what the mean is, but again, you're having to guess on each and every data point, because the data points fall in intervals, and you don't know if there are 3 items between 10 and 20. Are all 3 of them 11? Are they all 19? You just don't know. You just know they're somewhere between 10 and 20. So there are a lot of ways that a histogram is kind of a dead end for me in statistics, because it's hard to take a histogram and generate any further information on it, because you lack specific data. So, and that may be another thing, is that it lacks specific data. You only have a range of where the data points fall. You don't know exactly where they are. So, all right, that is the end of the review. Good luck on the Cum test.